so now we move on to Smith-Waterman algorithm. Let me review about three main steps we have to follow. For the first step is initialization. Initialization means that you have to fill in the score at the first row and the first column, right? And the second step is matrix filling. You have to fill all of the cell in the matrix, and after you finish, you have to trace back. Trace from the back to the start to identify which path is the most optimal. Okay, so this is the three main steps that we have to work on. So let's take a look at the scoring matrix here. You have F0, 0. So F0, 0 means the first blank row. We have to put the score 0 here. The same things we did with Needleman-Wunsch algorithm. And then for Needleman-Wunsch algorithm, if we move to the left, we have to plus minus 1 because of the gap penalty, right? So here it means that if the first sequence has the nucleotide that identical to the second sequence, we will put the score 1. In other words, if the nucleotide are matched, we will put value +1. If in case they have mismatch, we will put -1. And if we have to add the gap, we have to put gap penalty score -1 as well. Okay, so we have to add the value here. We have to move from the left to the right, so we have to perform the addition by +1. So 0 minus 1 is -1, right? But if you look carefully at the scoring function of Smith-Waterman, we have to consider 0 as well. -1 and 0, we have to put 0 here because 0 is higher. And if you move to the left again, you have to perform addition with -1, but -1 compared to 0, 0 is higher, right? So we don't have to put arrow here. What we can do? In the first row, we have to add only 0 value. Same thing with the first column. So simply put, for Smith-Waterman algorithm, for the first row and the first column, you have to add 0 value. Okay, this is the first step we have to work on. And then for this cell, we have to consider from 3 directions and including, don't forget 0. Okay, so for the diagonal one first, diagonal one, we have G and A with each mismatch, so we have to add -1. 0 minus 1 equal to -1. Same thing from the top and from the left, we have to perform the addition with the gap penalty score, which is -1. 0 minus 1 -1. 0 minus 1 -1. You can see that the value from 3 directions is all -1. -1 compared to 0, 0 is higher, so we have to add 0 here. And element remove the arrow and score. Okay. Next, we have to consider the value from 3 different directions. For the diagonal one, we have G and C, right? G and C is mismatch, so we have to add -1. 0 minus 1 is -1. G and C, from the top and from the left, we have to add with gap penalty score -1. -1, -1, and all are -1. Compared to 0, 0 is higher, so 0 is the maximum score. In this case, we put 0 in the cell and remove the value and arrow. Okay, so next cell, we have to consider from 3 directions, also 0. As you can see here, G and G is matched for the diagonal direction, so we will put 0 plus match score 1 plus 1. And for the top and for the left, we will add with -1, so -1 and -1. The maximum value in this case is 1 here, not 0 in this case, so we put 1 in this cell, right? And 1 come from the diagonal line. Don't forget to put arrow from diagonal line and leave other score out. Okay, so now we got only 1 arrow here. For the next cell, we have to consider 0, of course, diagonal, top 1, left 1. You can see from this cell that you have A and A, right? A and A is matched. So the diagonal line, we will put 0 plus match score 1 here. For the top cell, we will add gap penalty score -1. 0 minus 1 minus 1. The same thing we'll do with the left cell. 0 minus 1 minus 1. So the maximum value will be 1. We put 1 here. And 1 here come from diagonal direction, so we will keep the arrow from diagonal cell. We will go on to the next cell here. So we consider 0, left cell, diagonal cell, top cell. We see that from diagonal 1, A and C is mismatched. So we will put -1 here. Same thing here, -1. And same thing here, 1 minus 1 is 0. You can see that the value is 0. 0 can be here or the default values, right? But we will keep the arrow from this direction as well. We remove the rest out. Okay, we'll go on to the next cell. Put 0 first, left, diagonal, the top. You can see that this is from the diagonal value. We compare A and G, which is mismatch. So we will put the score -1, right? From the top, 1 minus 1 from the gap penalty will be 0, right? Will be 0. And 0 minus 1 will be -1. The maximum value is 0, okay? 0 from default and 0 from the top cell. So we will put the 0 value here. and then we will remove the rest. Okay, all right, we will go on to the next row. We have to consider 0 from the default scoring function, left diagonal and top one. This one diagonal first, C and A is mismatched, so we will put -1 here. 1 minus 1 is 0. 0 minus 1 minus 1. So the maximum value is 0. We put 0 here and leave the rest out of the way. Okay, so go on. We consider 0, top, diagonal, left. We found that this cell had C and C, right? C and C from diagonal 1, we found match. So 1 plus match score 1 will be 2. From top cell and left cell, we have to add with gap penalty -1, 0 minus 1 will be -1, 0 minus 1 will be -1. So the maximum value will be 2. That comes from the diagonal line, right? Okay, so this is the maximum value. The last cell that we have to consider, we have to consider 0 from the default scoring function, left cell diagonal and the top. For diagonal 1, C and G is mismatched, so we have to add -1 mismatch score. From the left, 2 minus 1 is 1. From the top, 0 minus 1 is -1. So the maximum value from 4 directions will be 1. So 1 comes from the left cell, so we will remove the rest out of the way. So this is we have done in the step 2 matrix filling. What we're going to do next is to trace back. So the maximum value in these the last row is 0. Oh, sorry, not 0, 2, right? 2 is the highest value in this case. 2, the arrow point here, we have to highlight the arrow from the diagonal line because 1 gives 2 value, right? We have to highlight 1 value here in this cell, and 1 come from diagonal value here, right, which has the score 0. Highlight here, right? Okay, so now we got this one is the most optimal path of the alignment. Okay, so let me summarize here. So from the scoring matrix, we found a path here for sequence 1 and sequence 2, right? So start with the back first because it's called trace back, right? Back, start from the back first. C and C found in both sequence. C and C. Go up here diagonally. If you go diagonally, it means that it's like a 2 match nucleotide. So we found A and A out before C, right? And you can see here, go back here, you can see G that come from sequence 1, right? We have sequence 1 here and we have sequence 2 here. So from here in sequence 1 we have G, right? And for sequence 2 we have G here. So the match nucleotide is shown in the red box here. So this is how the uh, algorithm, Smith-Waterman algorithm, align the sequence. This is a very easy example for short sequence, but if you work with the longer sequence, it will be useful to identify um, which location, which position in the sequence that you have to put the gap in between. So the location or the position of the gap you can infer from the alignment score. Okay, this is the first example of easy Smith-Waterman algorithm. I hope you can understand this subjects, and if you have any question, please don't hesitate to ask me. Thank you for your attention.